Now that we have introduced parallelograms, we're going to focus on three specific types of special parallelograms. So we have discussed what a parallelogram is. We know that quadrilateral is something with four sides. And so this time we're going to focus on these three shapes: a rectangle, a rhombus, and a square. And we're going to look at how these are connected to each other and what properties make them distinct. But all of these shapes will have properties of a parallelogram because they are all types of parallelograms. So one of the resources that you will have is a reference sheet where you will be able to see exactly what properties are we talking about. So, for example, we just talked about how all the properties of a parallelogram will hold true for my new three shapes. However, there are some other properties that are true specifically for each of my other types of shapes. And so we're going to break that down and just focus on looking at those properties today. But this reference sheet is available to you, so make sure that you are using this as a resource so that you have access to what those properties are and for which shapes they are true. The first shape we are going to talk about is a rectangle. The definition of a rectangle says that it has four right angles. All of these angles are 90 degrees because that's the definition of a right angle. And if this is all you know, this is enough to say this is a rectangle. And because you know it's a rectangle, all the properties of the parallelogram are also true for it. But we also know in a rectangle that the diagonals are congruent. So that means that this diagonal that I've highlighted pink is congruent to all of this diagonal, which we highlighted purple. We cannot say that when we were talking about parallelograms, but when we talk specifically about rectangles, all four of those pieces are congruent to each other. And we know when things are congruent that we will end up setting them equal. The next shape we're going to talk about is a rhombus. A rhombus has two things that are true about its diagonals. We know that the diagonals are perpendicular, which means they make 90-degree angles. So this part where the diagonals cross, every single little angle made here by where our diagonals intersect, all of those are right angles. And if you know that one of them is a right angle, then you know that the other four are also right angles. The other thing that is true here is that the diagonals bisect opposite angles. Now there's a couple words that are happening here. We have bisect, which means we know is cut in half, and we talked about diagonals being bisected for a parallelogram. But what's different is that for a rhombus, that means that if I look at just this diagonal takes opposite angles and it cuts them in half. So these pieces are congruent and these pieces are congruent, and all four of those angles are congruent to each other. The same thing can be said for the other diagonal, but these are only congruent to the pieces that touch this diagonal. So this doesn't mean that all of the bisected angles are congruent to each other, but all the ones that touch the diagonals. So I have my orange diagonal, all four of those angles are congruent to each other. I have my blue diagonal, all four of those angles are congruent to each other. And that's what it means when we say diagonals bisect opposite angles. Then when we talk about diagonals are perpendicular, that's where the two diagonals together make a 90-degree angle in the center. I highly recommend that for the property where you are needing to talk about diagonals bisecting opposite angles, this is the most commonly missed property. So I highly recommend that you follow those steps to highlight each diagonal in a different color. And that way you can easily visualize what am I talking about when I say that the all four of those little parts are congruent. Because if you take a problem and you highlight it in those two different colors, you'll be able to visualize exactly what we're looking for. And when we later go through solving for these kinds of problems, we'll take a closer look at that, and I will model that for you when we work through those problems. A rhombus has four congruent sides, so that means that all of these sides are congruent, and that's A equals B for solving. So the four congruent sides is the basic definition for a rhombus. Four right angles is the basic definition for a rectangle. When I take those two and I put them together, I find that I have a square. A square has both four right angles and it has four congruent sides. So I'm going to go ahead and just draw. If you see both of those at once, you must have four right angles and four congruent sides. If you do not have both of these things true, then it's either a rhombus or a rectangle. But if they're both true at the same time, then a square has all the properties of a parallelogram, all the properties of a rectangle, all the properties of a rhombus. So let's go ahead and practice recognizing what kind of shape we have. So all of the shapes that I've drawn for these examples look like squares if you don't know your properties. So don't look at, oh, well, this looks like a square, so it must be a square. No, we have to go look at our chart and we have to decide what property is being shown. So when I see that I have two diagonals that make a right angle, that is that the diagonals are perpendicular. If I go look at my chart, I have a check that the diagonals are perpendicular next to my rhombus. So that means that this shape must be a rhombus. When I'm looking at this example, I see that I have the arrows, and remember, whenever I see arrows on my pictures of quadrilaterals, that means I'm dealing with things that are parallel. And the only property that I have that says anything about parallel is that my opposite sides are parallel. And I do see that. The sides that don't touch are parallel to each other. And so that means that I must have a parallelogram. And I know it's a parallelogram for the most specific name because even though it could be all of these other shapes, I don't know any properties that are specific to those other shapes. I only know the property that says that is true for at least a parallelogram. We're looking for the most specific name. So for this shape, I have AC is congruent to BD. So I have this diagonal right here is congruent to this diagonal right here. So I know there are two properties that do talk about things that have diagonals that are looking congruent, but one of those says that the two entire diagonals are congruent to each other, and that would be this property right here. And if I look at my chart, diagonals are congruent means that I must be dealing with a rectangle. This shape has two things that are true. I have my four right angles, and that right there means that I could have a rectangle or I could have a square, but I also have four congruent sides. And when I have four congruent sides and four right angles, when I can say that both of these are true, that is how I know that I have a square.